I'm Andrea Shear. I'm an engineer with Wisciani Elsner Associates in the New York office. So I'm a structural engineer. I focus mostly on repair, assessment of existing structures, and renovation of existing structures, adaptive reuse type work as well. I'm really interested in kind of the history and how we got here, why cities are built, how they are, and history of the construction industry in general. I find steel framing to be very adaptable. You see where the load path is really readily. You can pretty easily find places where you can cut holes for new plumbing or ductwork and stuff like that. So yeah, I really see steel as being a very adaptable material. It's really easy to repurpose buildings and understand the construction. So I think it's the first level of sustainability. We've spent all this energy to construct these buildings. The most sustainable thing we can do is take care of them in the state that they are. Steel in particular is a pretty interesting industry, right, with the development of steel mills and different fabrication processes, and how they were improved over time. In the mid to late 1800s, everything was iron. So we looked at cast iron and wrought iron, and we still see, especially in New York City, a lot of buildings that have those elements still part of them today. Steel really took off and overtook iron in construction in the early 1900s. When we look at a building, we don't necessarily know if it's iron versus steel, so we have to do some testing to understand what we're working with. They started out making steel, and there were a lot of defects in the steel. Things weren't welded regularly until the post-World War II, so the early to mid-50s. Prior to that, weldability wasn't a quality that people were looking for in steel. Things were bolted or riveted. When we look at an older building and we're trying to weld things back into it, we have to understand the defects that we're dealing with and how to make them how to make reliable connections to material that may not have the level of reliability that we deal with today. If you're dealing with wrought iron or cast iron, it's really preferable to bolt your connections. Cast iron has a very high carbon content, which is just not very good for any type of weld or any type of ductility. Well, one interesting example that I have is a building on Park Avenue in New York City where, now we think of Park Avenue as like strictly office. Manhattan, as it developed, moved north, and this building at the time that it was built was kind of on the northern side of the developed area, and they didn't know what the use of the building was going to be. So they actually designed the floor loads to be 120 PSF. Now, it's used as an office now. They don't need 120 PSF capacity. They really only need the 50 PSF. But it's cool because when different tenants come in and they want to do different modifications, we know that the floor has the capacity to take the additional load, and we don't really have to worry about spending the money on a retrofit or adding new beams to support heavier loads, because they did build that building with the idea that it could be used as different types of different uses, basically. Yeah, no one wants to pay the extra money up front, but a little bit of extra capacity goes a long way in the life of a building. Yeah, actually, one of the more exciting projects that I worked on was a parking garage where the base of a column, there was asphalt that was basically in direct contact with the steel. And because the asphalt is a porous material, it allows the moisture and the fluorides to kind of pond at the base there. And because the asphalt's directly against the steel, you don't see the steel section. So there's corrosion happening and you don't see it. And actually, that garage, the column locally buckled beneath the asphalt. And so the deck dropped probably 3 or 4 inches, which obviously is not a good condition to have a column failure in your structure. But we came in, put some emergency shoring in, we're able to jack the structure back up to its original location, cut the bad section of the column out, put a new section of column in, repaired the other columns that had similar conditions, and so basically back to new. Put a good coating on it, encased it in concrete now at the base so we don't have similar condition continuing. We have various different tools for different materials. Concrete, I would say at this point, GPR, ground penetrating radar, is the most common tool that we use. At this point, it's like a very small handheld device that's really easy to carry around. And I mean, it's radar, so it sends a radar wave through the structure and reads the reflection. And so you get the printout on the screen, and you can see, just depending on how you have the settings, a reflection of where either the reinforcing steel bar is or the backside of the slab. You know, there's different tools that you can use for different things too. Another thing that we use pretty regularly is just a rebar locator that's magnetic. So it'll just give you really a sound that'll indicate when you're close to the steel. We use ultrasonic thickness gauges very regularly, because particularly if you're trying to figure out the web thickness, unless you have the end of a beam exposed, you don't get that. AISC has Design Guide 15 that has a list of all the known structural shapes that were historically produced. So we pretty commonly, when we start on a building, if we don't have drawings available, which is unfortunately very common, do some measurements on the steel beam and use that ultrasonic thickness testing, both to like measure the web thickness, but also to evaluate any corrosion and the remaining section thickness in the corroded areas.